Alright, section B. Explain the role of an algorithm in the problem-solving process. Explain the role of an algorithm in the problem-solving process. What shall we say? We shall say for 2 marks, an algorithm creates a list of steps to be carried out that can be easily translated to program code. Cool. Yeah. Alright, examine the 2 algorithms below, label algorithm 1 and algorithm 2, and answer the questions that follow. Alright, so the first algorithm is a for loop that goes 15 times, and I'm just printing the value of x, which is the counter. So that's going to print 0 to 15 on the screen. Cool. Next one will be read x while x is not equal to 999. Do sum is equal to sum plus x, so we add any value of x that the user is putting in. Which of the algorithm explains a bounded iteration? Well, algorithm 1, algorithm 1, because you know when it will start and finish. Pretty much. Algorithm 2, because the condition to end the loop is determined by a variable that is input. Pretty much, that's it there. Algorithm 1, algorithm 2. That was easy. 6, 8 marks you get here, like for free, almost. Alright, no questions. We good. Alright, a primary school is conducting a survey. Oh my goodness. I'm fed up seeing, okay, I'm not fed up seeing this question, but I mean, by now, you all know how to do this question because you've seen it so many times. So primary school doing a survey on certain colors, and they have to determine which one is the color that they want to choose. The survey is 150 students. So you have to do a for loop for it and check to see which color they put in. Where can I squeeze in this answer? It's a very straightforward answer. Next one, construct a flowchart. I'll do the flowchart right here. Alright, I'll write it in on the side. Okay, so we're conducting a survey on the popularity of certain colors. Students are asked to vote for the colors. So we have red, blue, and green, or none. If red, blue, or green is not the favorite, students vote for none. Write an algorithm to print the number of students that voted for each of the colors. So that means each color must be tallied. Total number of students that voted for red, blue, or green. Print the number of students that voted for each of the colors and the total number of students that voted for red, blue, or green, meaning that they made a choice and they didn't choose none. Assume that on the day of the survey, 150 students were present, and assume that all votes are valid. Alright. So we go in with algorithm to find votes. The variables I want to put will be R total, B total, and G total. and then we have to get total itself. Do we have to keep track of none? No, they didn't ask us to print out the non total, so that's okay. All right, cool. All right, so start print. No, it's 150 times. So I could just put the loop one time. Add a bar counter C. For C is equal to 1 to 152. I am going to print enter your vote and read V for vote. So I'll put a variable for V. Read V for vote, and then I'm going to say if vote is equal to red, then R total is equal to R total plus 1, and then I can put the total is equal to total plus 1 here because I got a valid vote. But then that would be kind of inefficient. It would be kind of weird. Okay, I have a different way of doing it. I'll get the total for none and then just subtract it. Alright, so I'll put n total. That's for none, if you vote for none, right? If vote is equal to blue, then B total is equal to B total plus 1. And then if again vote is equal to green, if vote is equal to green, then G total is equal to G total plus 1. Now you could put the totals inside each one of these and just keep adding total is equal to total plus 1 depending on whichever if you're in. Or you could do what I'm going to try to do here, which is if vote is equal to none, then n total is equal to n total plus 1. And then we could end the for loop. And after end the for loop, I could say total is equal to 150 minus n total. Because the amount of nones I get would be, if I subtract that from 150, I'll get the total number of students that voted for red, blue, or green here. And then I'm just going to print it out. So I'm going to print red colon R total, comma, green G total, and blue B total. Yeah, so I'll print those out and then I'll print overall votes would be total, and then stop. Does that encompass everything? Yep, that encompasses everything. Any questions there? No? Alright, so let me go through the marks, see what we have. Alright, declaring all these variables here, I suspect that there would be 2 marks for all the variables I need to have. But the variables I have could be more or less that. You don't have to have the n total like I do. So that's 2 marks there. Then will they give you 2 marks for the for loop or 1 mark for the for loop? Sometimes they get 2 marks for the for loop, sometimes they get 1. So I'll start off with 1 and I'll go through the rest and see if I can come back and get the 1 mark there. Please enter your vote. You get 1 mark for prompting and enter the vote. You get a mark for the if it is correct, and then a mark for that. Then you will probably get another mark for replicating that concept, because you can't get a mark for doing it just the ifs the same way over and over. And then you will get a mark for either, however you figure out to do the final total. You could do the final total by either inserting the line here for total is equal to total plus 1, or you could do it like this, which you get the total at the end and then subtract it, right? But either way, it's definitely 1 mark for figuring out the total. Somehow, some way you're gonna do that, right? Then they specifically said they needed to print out the stuff, so you're gonna get a mark for printing out that one. You're gonna get a mark for printing out that one. How much I so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I get 10 marks there already. Alright, cool. So it's 10 marks. That would be 10 marks based on my experience. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, Jasmine. If you do looking at what version, sorry? Oh, else if, the else ifs. Yeah, once the end if match up with the if, when you indent it. So yeah, so if the vote is red, else if vote is blue, else if vote is green, else none, and then end if them going all the way back here. But as I told y'all, sometimes some people are comfortable with doing just straight ifs each time, and then some people are comfortable with embedded ifs. Either way still works. Alright, now write an algorithm that uses iteration to find the sum of all the multiples of 4 and all the multiples of 7 between m and n inclusive. Alright. Space, do I have space? I'll put it on the left side here. Part D. So we know where we're starting, we know where we're finishing, so we're going at 4. 4c is equal to m to n 2. Right, we're starting from n and we're going to n inclusive, so they are there. Sum of all the multiples of 4 and all the multiples of 7. Alright, yeah, so for this question, for years I haven't really figured out if they wanted to find all the multiples of 4 in one sum and then all the multiples of 7 in another sum, or if they wanted the sum of all of them together. So I usually work it out with the sum together, because that way you could prove you're doing it both ways, either way. So we do the harder way, just in case the marks are for that. Alright, so let's go. We are going with if c mod 4 is equal to 0, then sum is equal to sum plus c, and if, and then we're doing if c mod 7 is equal to 0, then sum is equal to sum plus c, and if, and then and 4, and then we could print the sum, print sum. Yeah, so using mod is the best way to do it, because mod is just very easy at finding multiples. So you definitely get a mark for knowing the range that had to go from m to n. you're getting a mark for the if. Then you get a next mark for the condition. For the sub one, you get a next mark. Then adding up the sum each time is another mark. Then I don't know, 7 marks, right? Okay, you'll definitely get a mark for knowing to use if. I doubt the mark will repeat for using the if. 1, 2, 3, 4, 5. Okay, knowing that you have to use a for loop, will be our next mark. And then the last mark, I guess, will be print. Did they ask you to print? They said find the sum. Yeah, find the sum. I can't see what the 7 mark will be for, but let's assume that it's to print it out. Or maybe it could be for neatness. Either one, I'm not too sure. I wish I could tell you, but I can't. Alright, number 4a, construct a flowchart to represent the following algorithm. Alright, let's get the flowchart on the road. Flowcharts are easy marks. Begin, prompt 4 days. So begin should be start in an oval. Prompt 4 days. When you prompt in, that's a parallelogram. So you print in, enter num days. After you say enter num days, read num days. After I read num days, I'm setting day to 1. Day is equal to 1. That's in a rectangle because it's a process of assigning, or I have something else to set to. Day to 1 and total com equals 0. Total com equals 0, right? Then now I reached a while. A while is a diamond, so the diamond is day less than or equal to num days. If the answer is yes, I will read number item sold. Read. That's one long variable name though. Num items sold. And then I meet a next if, which is another diamond. This diamond says to me now, if number of items sold is less than 500, then the answer is yes. I'm going to say now, com is equal to num items sold multiplied by 4. Else, which will be the no, rectangle, com is equal to num items sold multiplied by 5. And when these two guys finish, doing their work, they are going to print. Because we're still inside our while loop, We are still inside a while loop. We're going to print com And after that now, add 1 to D. So that is a rectangle. Add 1 to D. And now this now is going to find its way all the way back up to check here. If D is less than num Ds. And once that is not true, then the answer will be no. And we just go and print num Ds and total com. Right, now, and then we stop here. Right, so what I normally do with my flowcharts is I always try to make the decisions go to the right, because sometimes when you make the decisions go left, right, it kind of, you will have to start in the middle of the page and you wouldn't know how much space to use. But if you start at the left side of the page and then you make your decisions always go to the right, it's kind of easy to follow the flow and know when you're looping back. And that usually works out well. So, let me hear if you have any questions. Alright, so let me see now if I could break down the so let's see. Let us see. Print. Alright, no problem. So let's see, 12 marks. You're getting, usually, just for the proper use of a shape, in concession, it'll be like 1 mark, right? So this will definitely be 1 mark because you read both of them there. This rectangle for the assignment will be 1 mark. This diamond being there for the less than will be 1 mark. Yes and no. Yes and no will be 1 mark here, meaning that you know what the yeses and nos would be doing. And then there is the parallelogram for reading the number sold. I guess, yeah, that'll be 1 mark. Then you get a next mark for your decision here, a next mark for yes and no. And then for each one of these, you're getting 1 mark for your rectangle, because it's a calculation by 4 and a calculation by 5. So you're only going to get a mark for knowing to multiply by 4, multiply by 5. It's really to make sure you know both of those shapes have to be rectangles. Then you're going to print, so there's a mark there, adding 1 to the D, which is a rectangle, because that's a calculation. And then you definitely get a mark for looping this back properly. And then you get a mark for printing out. I hope that's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, 12 marks. Yep. That seems like it there. Alright, let's see. Next one says the algorithm shown below what would the algorithm print given the line input of data below? Okay, so we have an algorithm that's going to be reading a value of J and then printing the value of J and then reading on the value of J each time. Okay, so we're reading J first. So that J we read, sum is equal to 0. And then we're just calculating down the road. So let's try this and see. Read J. So we're going to get the J is 3. Sum is equal to 0. While J is less than 5. Okay, while 3 is less than 5. Cool, what do we do? Sum is equal to sum plus J. So sum is equal to 0 plus J. So sum will be equal to 3. Sum becomes 3. It says print J. J never changed, so J is still 3. So we're going to print on the screen 3. Okay, let's just do a trace table fit because it clearly said show your working. So if it says show your working and we're tracing through our algorithm, the most logical thing to do is do a trace table. So let's just do a trace table and save ourselves the drama. So we have a variable J and then we have a variable sum. So J starts off at 3, that's the input that we get. Sum will be 3 because we figured that out. And then the output will be 3 because the output is basically what is printed, which is J. Next time we loop now, we're going to read a new J and we're going to get a 2. So we're going to go back up here while j is less than 5. J is now 2. Is 2 less than 5? Yes, it is. So therefore, we're going to calculate sum is equal to sum plus h. Sum is currently 3. So 3 plus 2 is going to give me 5. Then they're going to print out j. So the 5 will end up out there. Then I'm going to read a new j, which is 1. I read the 1. Is 1 less than 5? Yes, it is. So 5 plus 1 will give me 6, so the output will be 6. And then now we have a problem because this is going to read 5. When we read the 5 in for j, the loop now is going to be like, hey, hold on. J 5 is not less than 5, so therefore the loop will stop. And then it'll just print sum, so the output will be 6. Yeah. Cool. Alright. And look, our favorite guy. Nice little symbol. Trace through the execution of the following algorithm and draw the output in your answer booklet exactly as it would be generated by the algorithm. You should carefully note the following. Alright. Print spaces n. Print spaces n from the current cursor position. Print continuous output on the current line. Alright, so print n, this will most likely be a number on the inside that tells us how much times we need to put spaces. Usually we represent the spaces with a dash, right? Print continuous output on the current line from the current cursor position. Cool. Print line terminates the output on the current line at the current cursor position. Any subsequent output begins on the new line, so that means you'll put the output and go to the next line. Print line output list, outputs, output list on the current line, and then places the cursor at the beginning of the following line. So there are two types of print lines. There's normal print line, which will print one thing, and that's like line 18, which will just print a blank space and go to the next line. Well, print nothing and go to the next line. And then print line with a bracket will print whatever it is and then go to the next line. So let's go. Size is equal to 10. Size is 10. Print spaces, size plus 1. So that's 11 spaces. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11 spaces. And then now we're going to print line a star. Print line a star means print the star, and the next output goes here. Next line. Now we have introduced something called j. J is equal to size minus 2, so j will be equal to 8 because 10 minus 2 will be 8. And now we're checking to see while j is greater than or equal to 0. Is j greater than or equal to 0? Yes, j is equal to 8. So we're going to start following these instructions inside this while loop here as long as j is greater than or equal to 0. So print spaces j plus 1. J is 8, so we print in 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 spaces. Then we're going to print a $sign. And then print spaces size minus j, which is 10 minus 8 at this point in time. So that's 2 spaces, 1, 2 spaces. And then print an and sign. That looks like an and sign there. Then j is equal to j minus 2, so j becomes now 6. My j is heavily deformed. J is equal to 6, right? Then what happens? Or we go back up to the while loop. Is j greater than or equal to 0? Yes, it is. So we print in spaces j plus 1, which will be 6 plus 1, which will be 7 spaces. 1, 2, 3, 4, 5, 6, 7 spaces. I print the 7 spaces and then I print the $sign. And then I have to print spaces size minus j, which will be 4 spaces. So that'll be 1, 2, 3, 4 spaces. And after I print those 4 spaces, I print in an and sign again. And then j is equal to j minus 2, which will take j down to 4. So now that the j is 4, I'm printing spaces j plus 1, which will be 5 spaces. 1, 2, 3, 4, 5 spaces. and on the 5th space I'm printing a $, and then I have to print spaces size minus j, that's 10 minus 4, which is 6. 1, 2, 3, 4, 5, 6. I put the 6 in, and then I put the and sign, and the and sign goes on. J is equal to j minus 2. J is equal to 2. Then 1, 2, 3, 4, no, 3 spaces. I print the $, and then size minus j, which will be 8 now. 1, 2, 3, 4, 5, 6, 7, 8, and sign. And then j becomes 0. Is 0 greater than or equal to 0? Yes, it is equal to 0. So print spaces 1. So print the 1 space. After I print the 1 space, I print the $, and then same drama, which will be 10 take away 0, which will be 10 spaces. 1, 3, 4, 5, 6, 7, 8, 9, 10, and I print the and sign. And now j will become -2, so therefore I can't use j anymore. So I'll just stop the while loop because the while loop has elapsed. The condition has been met. Then it says print spaces 1. Print spaces 1 means, okay, print 1 space. So I print the 1 space. Cool. For j is equal to 1 to size plus 1. Size never changed from 10 to this 10 plus 1, which will give me 11. So from 1 to 11, I print in plus signs. Let's see what happens when I do that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Well, that is an awkward shape. It's like a triangle that they cut the tip off. But that would be the answer. Did you get that? Alright. Nobody gets? Alright. Malia, what about you? Which part did you all kind of mess up? Did you lose it like within the while loop? Okay. Alright, so 10 marks would be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. I don't understand how they'll give you marks with 2, 4, 6, 8, 10. I can't see the 10 marks. It's baffling me. I'm not too sure. I would assume that the first and the last line are 1 mark each because they don't really ask it to do anything special. Then the next line, 1, 2, 3, 4, 5. Nope, not a clue. Alright, I'm gonna take a guess at how to mark this because honestly, I'm not sure. So the first line will be 1 mark, clearly, because that's just to follow 1 instruction. No, the last line actually has 2 instructions. 2, 4, 1, 2, 3, 4, 5, 6, 7. Whoa! Alright, let's just see me get the line or the line of all the ands in 1. That's correct. And for every $, 1, 2, 3, 4, 5. Alright, you go. For every $, you get 1 mark. So that'll be 1 by 5. So 5, 6, 7, 8. Oh, it says print spaces 1, so that'll be 1 mark there for 9 marks. And yeah, the 10th mark, I don't know. Neatness. Don't know. How would they give you the 10 marks, but that's basically the answer there.